Hi class, welcome to another section on 3.2. This is the third day on this one. 3.2 day 1 was just talking about substitution, elimination, and graphing. And then 3.2 day 2 was when we had our word problems, our story problems. And so now this is the second day of our story problems, which is the third day of section 3.2. I hope that makes sense. So we're doing our word problems again today. And just like yesterday, they're going to be kind of similar. And so hopefully if you didn't have a whole lot of success on the first day of our story problems, the more you do these, the better you get at them. So hopefully now on this lesson you're going to have more success. So if you would like to, I would just like you to maybe skim through these notes on our story problems day 2 notes. If you want to, you could try some of those on your own, see how well you come up with them. It's good to kind of critically think about them. You don't even have to solve them with using systems of equations. You could just use your knowledge of coins, and you could use your knowledge of ages and stuff like that, and just see if you can solve these using your own methods, and then you could check them over with mine. So if you want to, you could pause the video, and why don't you do that right now. We're going to start here with number 1. Number 1, Henry is 9 more than 3 times as old as Sophia. In 20 years, the sum of their ages will be 105. How old is Henry now? So you can do this by guessing and checking. That isn't the most efficient way. The most efficient way is by setting up a system of equations. So let's first talk about the first sentence, which is written in blue. Henry. We'll just say Henry is the letter H. We defined Henry as H. Henry is means equals. Henry equals 9 more than 3 times as old as Sophia. So 9 more than. That means whatever 3 times Sophia is, you have to add 9 to it. It's 9 more than that. So we're going to add 9 to what? We're going to add 9 to 3 times as old as Sophia is. So 3 times Sophia plus 9. I have this little dash through my S. That way it doesn't look like a 5. I've had mistakes where I've written this, and some people think it looks like this. So as you can see, I tried to denote my S's by putting a dash through it. So that's why I have that. That S with a dash through it just tells me it's a variable and not a number. So I hope that makes sense for my first one. Henry is 9 more than 3 times as old as Sophia. So that's how I got that first equation. Second equation, in red. In 20 years, the sum of their ages will be 105. So in 20 years, if Henry is this old right now, he's H. In 20 years, he's going to be 20 years older. This is Henry's age now. In 20 years, which is Henry plus 20. In 20 years, the sum of their ages, so both of them, so Sophia will also be 20 years older, correct? The sum of their ages, so sum means adding, so Henry's age and Sophia's age, the sum of them, so adding them together, will be, which means equals, will be 105. There you are, class. You have your systems of equations. First one in blue, the second one in red. Now all you have to do is solve for it using substitution or elimination. I would recommend using substitution on this one because H is already solved for. H equals 3s plus 9. So in for this H, you're going to put 3s plus 9. So we have 3s plus 9 plus 20 plus s plus 20 equals 105. Let's solve for s. Combining like terms, 3s plus 1s is 4s. 9 and 20 makes 49. That equals 105. Let's subtract 49 from both sides. And when we subtract 49, we get 56. 4s equals 56. And then we have to divide both sides by 4. And so when we divide both sides by 4, we get Sophia to be 14. Sophia is 56 divided by 4 is 14. So now let's go back up to the top. How old is Sophia? That's what we found. That's not our question, though. Our question is, how old is Henry? Henry is not 14. Henry is 9 more than 3 times Sophia, which is 14. So 3 times Sophia, who is 14, 9 more than that. That is how old Henry is. That is obviously this equation right up top here. So 3 times 14, that would be 42. And 42 plus 9, Henry is 51 years old. If you want to, you could always check your work. Looking at the second equation, it says in 20 years, the sum of their ages will be 105. So in 20 years, what's 14 and 20? 34. What's 51 and 20? 71. The sum of their ages is 105. Is that what it says? Absolutely it does right there. So you could always check your work with these substitution and elimination problems as well. Let me know if you have any questions when you come to class tomorrow.